So, good evening. Welcome to today's class, Math 106. So today we'll be looking at integration. I will be taking you through integration, and that's the next of the handbook. So I will be taking you through that today. Integration is an opposite of differentiation, and I plan to call it anti-differentiation because actually the opposite of differentiation. Any function that you differentiate, when you integrate it, you go back to the function, and that's why we call it anti-differentiation. So I will just go straight to examples where I understand how it's being done. So Integration is an anti-differentiation, as we all know. So, let me see this. Can you see the button?
We can see, but the writing is a bit tiny.
You can see. So,
yes.
Okay. So, integration. Let's look at the example. Given that integral of s dx, or let me say integral of n raised to power m dx.
Right, mute your mic.
So when you have to integrate n s raised to power n, so what to integrate is with respect to s. To integrate, so whatever that is the power of s, you have to add 1 to it, and that's what integration is all about. So as it is now, we have m as the power of s. So once you do that, this will now be n s raised to power n plus 1. That same n plus 1 that you have as the power, you will now use it to divide it. n plus 1, then you say plus c. That c is what we call integrated constant. In some book, instead of c, you see it as k, but they are referring to it as integrated constant. So once you do this, once you add 1 to the power and use it to divide the function, you don't need to put integral sign again, and that gives you integration. This is a general case. But let me take a better example than we have now. Example now. Let's say you are given integral of s squared dx. You have to integrate s squared dx. What you just need to do, add 1 to the power of s. Already we have 2 there. This will give you s raised to power 2 plus 1. So what you have as a power now, use it to divide. At any time you put plus, at any time you add 1 to the power, you don't put the integral sign again. You don't put this integral sign again. So we are now adding this 1 to the power, then you use it to divide it. This is now the 2 plus 1. Then you say plus c. So 2 plus 1 will give you 3. This is over 3, then plus c. So integration of s squared will give you s raised to power 3 over 3. More example. Let's say you have to integrate another example now. 7s raised to power, or let me say 7s raised to power 3 dx. You do the same thing by adding 1 to the power. What we have before s, we are not so much concerned about it, but the power of s is our major interest when it comes to integration. And at any time you carry out the integration, at any time you add 1 to the power and use it to divide it, you are meant to put plus c. If you don't put plus c, then your answer is not complete. This plus c is very important when it comes to integration. So to do this one, this will be 7s 3 plus 1 over 3 plus 1, then plus c. So this can be 7s raised to power 4 over 4, then plus c. That is the integration for that. Now, let's now look at another example. What about we are now asked to integrate just, we are asked to integrate 3s squared dx. The same thing, add 1 to the power of s. The power of s here is 2. By the time you add 1 to it, that will give you 3. And use that 3 to divide it again. So this can be 2, not 2. Already we have the power of s will be 2. So you are adding 1 to it, this will be over 3. Then use it to divide it over 3. So this 3 here can cancel 3. Then this will be s raised to power 3 plus c. So that is the basic form of how to solve integral or integration. Let me take more examples still on integration. I'm hopefully trying to lay foundation. So let's say you are asked to integrate just 5 dx. You are asked to integrate 5 dx. Now, what you have been working on is s. But if you look at this one, there's no s here. Unlike all the one we have been solving that we had 1 to the power of s. But in this very one, there's no s. What do we do? You will agree with me that integral of 5 dx can still be rewrite as 5 s raised to power 0 dx. You have to introduce that s into it so that you can solve. Now, if you look at this s raised to power 0, according to law of physics, n raised to power 0 is 1. So what I have now does not dictate from the question. The question is 5 ds. And I'm not taking it to integral of 5 s raised to power 0 ds. The essence of this is that we must have s so that we can add 1 to the power. But as it is now, we are now having s raised to power 0. S raised to power 0 is still 1. It does not change the given question. So I will now integrate 5 s raised to power 0 by adding 1 to the power. So this will be 5 s 0 plus 1, then 0 plus 1, then plus c. So this will be 5s, 0 plus 1 is 1, then 1 plus c. And eventually this will give you 5s plus c. That will give you 5s, s raised to power 1 is the s. Then anything divided by 1 does not change the value. So invariably, we are now asked to integrate 7s. This will give you 7s plus c according to what we have here. We are asked to integrate, let's say 45 ds. This will give you 45s plus c. So that is integration for you. So let's now look at more examples still on integration. If you can now also integrate in bracket 2s squared plus 3s minus 5 dx. This I can solve the same way I've been doing others. I can rewrite this thing as integral. I can split it because everything is in bracket as it is. I can split it so that it will look like what I've been solving before now. So this can be 2s squared, and I'll put the s, plus integral 3s ds minus 5 ds. We all know the idea now. This is 2s raised to power 2. We have to add 1 to that 2. Then use it to divide it. That means when you add 1 to 2, that will give you 3. Then use 3 to divide. So if you integrate it, this will give you 2s raised to power 3. Then you divide it by 3. Plus, this one is having s3s. That means that s is raised to power 1 as it is, because it's just 3s. So when you say s is 3s raised to power 1, it's still the same thing as 3s. So already there is 1 on this. And the rule say add 1 to the power. By the time you add 1 to this power, this will give us 3s raised to power 2. Then you use that to divide it. Minus, then integrate 5. I've done that. When you integrate, once you integrate a constant, 5 is a constant because that's no s. Integration of a constant will only attract s to it. So if you integrate 1000, it will give you 1000 s. If you integrate 700, it will give you 700 s. So if you integrate 5, now that will give you 5s plus c. So when you integrate that function, this is what you have as the integral of that. So that is integration. Still on integration now. Still on integration. Now, if you are not asked to integrate 1 over s, I'm saying 1 over s. I'm not saying 1 over s squared now. If you are asked to integrate 1 over s, when it comes to integration, this can be taken as an identity, though there is a proof to it. But I don't want to bother you on the proof aspect of it. So integration of 1/s will give you ln s plus c. Please take note of this. This is a rule or an identity of integration. So when you have 1/s, the integral will be ln s plus c. Let's say you are given 5 5/s dx. As it is, I can rewrite it. I can take this 5 out of the integral. That is into 5 integral of 1/s. Yes, so that it will look like the first one. So if you integrate this will be 5 ln s plus c. So integration of 1/s is ln s ln. This ln means ln. Ln s. That's how you write it, but they are together. So it is ln s. So again, if we are asked to integrate 25/s ds, this will give you 25 ln s plus c. So take note of all these simple things. So let me give more examples still on integration. Let's say you are now asked to integrate. You are asked to integrate, let's say 5s raised to power 3. Okay, before this, let me give a new example now. Still on integration. You are now asked to integrate 1/s squared dx. To integrate 1/s squared dx is different from 1/s. To integrate this one, you have to go the route of what you have been doing before. But for this one has an identity, but this one has no identity. To integrate 1/s squared, I can, by law of indices, this 1/s squared, I can write it as s raised to power minus 2s. Then I will now apply the same rule that says add 1 to the power and use it to divide it. So when you apply the rule here, this will be s minus 2 plus 1 over minus 2 plus 1 then plus c. So this minus 2 plus 1 is minus 1. So this will be s raised to power minus 1 then over minus 1. So in mathematics, when you have minus, we don't normally put minus as the denominator, so we can take it off so that this thing can be minus s raised to power minus 1. Because when you divide this out, it will look like. And if you don't want to leave your answer, you can leave the answer this way. But if you don't want to leave the answer, this by law of indices can still be written as this. So that is by law of indices, this can change to this, and by law of indices, this can change to this. So if this can change to this, then this can change back to this. It's that same thing that I applied. So this can change back to this. So that is by law of indices. So when you have to integrate 1/s squared, it has no direct answer like 1/s. It's only the 1/s that came to ln s. You can have it 20/s, it will be 20 ln s. You can have it as 100/s, it will be 100 ln s. That is for that because it's a special function of logarithm, of integration. Then still another example. Let's say you are asked to integrate 2/s raised to power 3. 2/s raised to power 3 dx. By law of indices, just like what I did here, I can rewrite this as integral 2s minus 3 dx. So you can now apply your rule that says add 1 to the power and use it to divide it. So this will be 2s minus 3 plus 1, then minus 3 plus 1 plus c. Minus 3 plus 1 will give you minus 2. So this will be 2s minus 2 over the down one will give you minus 2. So this 2 here can cancel the 2 and it's up. Then I will have it as minus s minus 2. So by law of indices, this can be said that you keep the answer this way, or you will rewrite it in fraction form, just like I did for the first case here. So this I can write as minus 1 s to the power 2. Once you rewrite it, the minus here will no longer be there because you have turned it to fraction. or a division form. So the minus will no longer appear. So these are more examples of integration. Now let me give one more example before we go on to another aspect of integration. What I've been doing so far, the integration, okay, let me give another example before I talk further. Look at this example. Let's say I have to integrate 2x raised to the power 4 plus 3x raised to the power 3 minus 2x raised to the power 2 minus 7, everything over x raised to the power 2. Like this, the s. So let's quickly take this. After this, then I will go to another aspect of integration that is of importance in this class. So this I will split it just like the case of the first where I've done something related to that, but except that this is divided, everything is now divided by x. To solve this, I can write it as 2x raised to the power 4 over x squared, because x is dividing everything, the s plus integral 3x raised to the power 3 over x squared, the s minus 2x squared over x squared, the s, then minus integral 7x over x squared. So I've now reduced the problem to this. The x cancels. This will be 2x raised to the power 2, because this is x raised to the power 2, this is x raised to the power 4 can cancel the s, plus here, x raised to the power 2, the x raised to the power 3, this will just give me 3x s, minus then this x squared squared, this place will only give me 2x. Then the last one will be integral. Now I've told you, I've done something related to it, just like before the example I just finished up. I can take these two on to have it as 2x raised to the power minus the s. Then I can now apply the rule that says add 1 to the power and use it to divide it. When you do that here, this will be 2x raised to the power 3 over 3. By the time you add 1 to the power of m, which is 2, that will make it 3, then you use it to divide it. Plus 3, this is 3s. We assume that there is 1. This 3s can also be called 3s raised to the power 1. So we assume there is existing 1 on that x. Then by the time you add 1 to the s, this will give you s squared over 2 minus. I've solved something like this before, that is of integration of y, integration of the constant. So it will be attract x. So when you integrate those two, give you 2x minus. Then this is minus 2. By the time you add 1 to it, that will give you minus 1. So this will give us 7s. This will be minus 1 over minus 1 plus c. Then we can simplify where necessary. Over 3 plus 3s squared over 2 minus 2s. Minus here and minus here. The minus here and the minus here will cancel. This can become plus. Then we have 7s minus 1 plus c. You can leave the answer this way, or you will leave the answer as 2s raised to the power 3 over 3, 3s squared over 2 minus 2s plus 7 over s plus c. So that's the answer for that question. So integration basically can be classified into two. We have what we call definite integral and indefinite integral. Some will say finite integral and infinite integral. So what I've been solving so far, so I said integration can be classified into two. That is definite or finite integral, or you say indefinite or infinite integral. So these are the two cases of classification of integration. So far, what I've been working on is called infinite integral or indefinite integral. I've been solving so far, then we refer to them as indefinite or definite integral. So all the examples I've been saying of what I've been solving so far are indefinite integral. So let's now go to definite integral. All this in the I only take you to the application area of it because the proving this, there are some statements of theoretical statements in the handbook. So you don't really need it. It is meant for science students, and you are not science major. So what I've been solving so far is called infinite or indefinite integral. So let's now look at definite integral. It's still the same thing, but one thing may be different. So let's now look at definite integral or definite integration. In definite integration, we have the integral as a, the f of s, dx. So if we look at this, you can see that unlike the first set that we're solving, there's nothing like a, b. It has no limits. But for this, we have limits. So anyone that has limit like this is what we refer to as definite integral. But the one without limit is what we call indefinite integral. It's still the same method of solving, but except for the value, the integral will carry value down and one value up. And that should be just different. So sorry for that. So let me take an example on this. Example, the question can say integrate from 0 to, let's say 2 s raised to power 3 dx. So the first set of the solving has no value like this. But this is once you put value, that's what we refer to as definite integral. So you do the same thing. So we integrate this 2s raised to power 3. For integrate that, we are adding 1 to the power, just like we have been doing. So this will be 2s raised to power 4, then over 4. So the difference between definite integral and indefinite integral, one of that difference is that in the indefinite integral, we do plus c, which is an integrating constant. But in this case, we don't put plus. Since they are bound, they are definite. So we don't put plus c. What do? We now put a line that says 2. The limits come down to this place. So we now substitute the limit, the values, into the result we obtain. But before then, 2 year, this can reduce to s raised to power 4 over 2, then this is 0, 2. Then substitute 2 to where we have s. For this one, this will be 2 raised to power 4 over 2 minus, then substitute 0 to where you have s. This will be 0 raised to power 4 over 2. By the time you do it, everything here will give you, or this one will give you 0. Then this will be 2 raised to power 4. That is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this will give you 16 over 2, and this is 8. So the final answer that is expected when it comes to definite integral will just be figures to be values like this without any s or any variable attached to it. And there is no need for plus c. Don't put plus c when you are dealing with finite integral. Let me take one example of finite integral or definite integral. Let's say you have to integrate, let's say 1 to 2 of 2s plus 1 dx, or let me say plus 3 dx. Looking at this, integrate from 1 to 2, 2s plus 3. So if you ask to integrate this, we do the same thing, just like what we have been doing before now. Integrate this and integrate this. When you integrate 2s, this will give you 2s squared over 2. Already we know that there's 1 here. By the time you add 1 to it, that will give you 2, and use that 2 to divide it, and that's just integration. Then this is a constant, 3, just like the previous one I've done, where we have 5, 6, 7 like that. So when you integrate 3, it will only attract s, and that will give you 3s I told you don't need to put plus 6 because of the values, the limits, then you put 1 and 2. So the next thing to do is to substitute 2 to where you have s. Substitute 2 to where you have s. This will give you 2 into 2 raised to power 2 over 2 plus 3 into 2. So let's put all this in the bracket. Minus, then the next thing is to put 1. The first is to use the upper limit. Then next is to use the lower limit. Substitute 1, this will give you 2 into 1, squared over 2 plus 3 into 1. So this is 2 raised to power 2, that will give you 4. 4 times 2, that will give you 8. 8 divided by 2, that will give us 4. So here we are having 4 plus 6. So 3 times 2 is 6. Minus here, 1 raised to power 2 is 1. Times 2, that will give you 2. By the time 2 divided by 2, this will give you 1. Plus 3 times 1, 3. We are having, so this will give us 10 minus 4. So the final answer here is going to be 6. So that is a definite or a finite integral. So when it comes to integration, we have techniques of solving integration. We have techniques of solving integration. We have the techniques. Let me say, we have methods of solving integration. I call it method or you call it techniques. Method of solving integration. There we have 3 basic methods. I will talk about integration by substitution. The next one is integration by parts. Then the next one is integration by partial fraction. By partial fraction. So if time permits me, I will take you through the first two, but the third one, you don't need to bother yourself about it, because for you to use for you to solve integration by partial fraction on its own is a topic in mathematics. So for you to use solve integration by partial fraction, you must have a very good knowledge of partial fraction. And because partial fraction is a topic in mathematics on its own, a standing alone topic in mathematics. So I will not bother you about this, and nobody will give you questions that you will need to solve by partial fraction, because partial fraction is a topic on its own, and I cannot start taking you partial fraction just because I want to use it here. But let me just take you through integration by substitution. So in integration by substitution, I'm just taking 1 or 2 examples. With that, then I will go on to transcendental equations and other equations where substitution method is being applied. So let's say you are giving an example now. You also integrate let me say 2x over x squared plus 6 dx. Let's say you also integrate this. The method we have been using so far cannot work here. We cannot say add 1 to the power, add 1 to the power, and use it to the power. It will not work for this case. That will only work for a single function, a constant, or a polynomial. It will not work for a division or multiplication in polynomial. It may not work. So to use substitution method here, what do we do? I will see. There are 2 things here. So look at it. One of these two things, when you differentiate, you get the other one. This is 2s. When we differentiate 2s, that will just give us 2. But look at the down one, s squared plus 6. When you differentiate it, that will give us just 2s. So in that case, substitution method is the best method you can use to solve this. In the exam, question may not specify use substitution method, may not specify the particular method to use. But by you understanding the different how the method is being used or is being applied, you should know that this will work with substitution method. So to solve this with substitution method, this is what you do. The one that when you differentiate it, it will give you the other one. That is the one you'll be dealing with. I will now say let u equal to s squared plus 6. I say let u equal to 10s plus 6. Then I will differentiate this, the u, the s. Differentiation, I want to assume in your first semester you have done something like that. So when you differentiate this will just give us s.
Recording in progress.
What is it? Okay, you can see that we have the s here. In what we have the u, the s equal to 2s. So make the s the subject here. When you make the s the subject, you have the s equal to 2, the u over 2s. When you make the s the subject here, that's what you are going to have. Now that once you can identify your u, you can differentiate your u, and you can get you can make the s the subject. The problem is half solved. All what you need to do is to substitute everything back into the integral. So when you substitute back into the integral, we are now having integration of 2s. The down one, everything has been assumed to be u. So let it be u. Then the s that is here is obtained as the u over 2s. So if we look at this, we cancel this. So we are now having 1 over u du. So when you look at this very well, it's the same thing as those examples I saw before, that is of the integral of 1 over s dx. When I solve this, I say it's the same thing as x. So when you solve this, this will give you the u plus c. We are putting plus c because there's no limits. So it will give you plus c. Now, what is our u? U is s squared plus 6. I will now return it. This will be s squared plus 6, then plus c. And that will give you the solution to that problem. And that is how to deal with integration. So we have just read more. You can see from text we have limited time of content. Then we have different cases of integration that we can solve by substitution method. All the transcendental and trigonometric functions can be solved using substitution methods. If you are giving integrate sin s, you can use substitution method. If you are giving exponential, you can use substitution method to solve all those ones. So you may need to consult more books or read more on that because of the limited time. And actually, so I have less than 7 minutes to go. Let me quickly see if I can give one more example on integration. Okay, let's see. Okay, let me go to integration of special function, accidental function. Integration of transcendental function. When we say transcendental function, we are talking about function of like integration of s, exponential s, or something like integration of ln s, or things like that. But I will not bother you about the integration of logarithm because it's so difficult and nobody can give you a question in this direction to solve. So, integration of transcendental form. Sorry for that. So, like when you are given exponential s and you have to integrate, it will still give you exponential s plus c. I'm saying exponential s now. If this s is 2s, it will not work. But we are giving exponential s to integrate, it will still be the same thing as exponential s. But we are not giving exponential 2s, the s to integrate. What you just need to do, differentiate what is here. If you differentiate 2s, that will just give you 2. So the integration will be 2. The derivative, when you differentiate the power, anything that you have, just drop it and rewrite the problem. That will be the solution. Differentiate what is here, put it down, and rewrite the exponent. Let me give another example. We have to integrate 2s plus 3, exponential 2s plus 3. Yes, like this. All you need to do, differentiate what is here. When you differentiate that, that will just 2s plus 3. When you differentiate it, it will give you 2. So this will just be 2, then rewrite the problem. 2s plus 3 plus c. And that will give the solution to that problem. So because of my time, let me stop here. That next week, I can so that I can entertain questions. So this is my 8 weeks lecture with you. All other classes have been uploaded. Then today, next week will be my last class with you. So you can come up with questions if there is any, but I will try to rush through the remaining part. I think the remaining part of the topic we need to consider is probabilities and some other things. So I will take my time next week, if by the next 20 minutes, or if you have the time after the normal class hour, I can proceed, log out and come up again to continue the class with you, but that will be extra time. But before we go on, I don't know if you have questions, you can unmute yourself so that you can ask questions. You can unmute yourself to ask questions if there is any question.
Good evening, sir.
Yeah, you are welcome.
Sir, from what you are saying now, we should not expect questions from the exponential integral.
No, they can give you a question on exponential. I said nobody will give you a question on logarithm.
Okay, sir. Okay, sir.
But the exponential, that one is so simple to solve. You can see the way I solve it. It's so direct. Just differentiate the power, put it there, then rewrite the function. That's the solution.
Oh, okay, we should differentiate the power, not integrate it, sir. We should differentiate the power. Is that
yes,
okay.
you are dealing with the integration, but you just differentiate the power and put it the answer down, then rewrite the function given to you. Just like this. Differentiate the power. It's 2, and rewrite the problem. That is solution for exponential function.
Okay, sir. Thank you very much, sir.
It's a short form to it, but because there are other methods of solving it, but it may be long. Just the way I said it.
Thank you very much, sir.
It's okay. Any other question, please? I have about 2 minutes, 30 seconds to go before the thing will log me off. Question? Okay. If you don't have question, I will assume that you have a good understanding of what I've been saying so far. So just look for textbook or your handbook, but I've covered everything in the handbook. There are other aspects of it that you may need. Is this area of trigonometry function, sine, cos, tan. But for management students, you don't, even in your field work, all those sine, tan, cos are actually meant for science, not management students. You don't have anything to do with it. But to be management, engineering or science students, then it is important. So the next class will be on probability. You can read ahead or do any other thing that you think will help in the next class. But I'm expected to take it for 8 weeks. So today is my 8th class with you. But I will make myself available next week. So after next week, I will bring the class to an end next week. So, but in the class next week, I will come up as usual, and the first 20 minutes, I will explain probability and how you can handle probability. And you can also consult textbook, secondary school textbook. It's enough to take care of all these things. Even if you can have project maths, There's one mathematics, they call it mathematics project, further mathematics project. All these things are well explained here. So to assist, or if you see anyone around that can put you through some of those things. So just endeavor. What is important here is for you to pass, which is the #1 priority. So endeavor to do the needful, and I will make myself available next week so that we can continue. So that I will take you through the remaining part of the class. So I wish you the best. Enjoying the remaining part.
Thank you very much, sir.
Oh, you are welcome.
Thank you, sir.
So,
Sir, is case engineering maths by K Stroud? Is that
yes,
okay?
yes, you can get it in the engineering maths. The only topic you may not get in engineering maths is probability and all those annuity